Hi guys, so this lesson today you're going to be learning how to search in algorithms, okay, and how the search in algorithms work. Now, what you're going to be doing this lesson is you're going to describe the need for searching. So obviously, why do we search? What's the point in it? We're going to explain the difference between binary and linear searching, and then also you're going to compare and contrast binary to linear searching. Now you've probably come across both binary and linear, but I'm just going to show you how it actually searches in terms of computer science. Now all work today needs to be completed in your booklet, so please make sure you've got a pen. If you haven't, then make sure you pause this video now and make sure that you've got a pen in your hand and you've got your booklet. Booklets are all based in the cupboard, so TAs will know exactly where it is. Now, so searching for information. Now we search for information for a lot of different reasons. Say we're doing our Christmas shopping online. We are searching for the car. We are looking for a nice pair of trainers. We search for a lot of different things. If I want to search for a student, for instance, okay. Now we actually go through a process and we ask ourselves some questions. Now a computer does exactly the same thing to actually come up with the right answer. Now, what we find is, say if I say to you guys, right, I want you to search for what day is it next week on the 10th, for instance. Okay, now you can search that on Google. Now that will actually come up with an algorithm behind when you click search, it will come up with an algorithm to actually get the correct answers, and that's how it works. Now, when you're going to start obviously when you're going to start making your own programs in computer science, you need to understand this so you can start thinking about computationally how that actually works, but also mainly why. What's the point in it? Now, like I said before, there was two different types of searches. There is binary, and there is linear. Okay, so they're two keywords, right? Anything on that screen you can copy down into your booklet if you think it's necessary. That's fine. Pause this video and get it down. No problem at all. Okay. Binary search. Now, binary search relies on something called a divide and conquer strategy, which is basically a series of questions and a series of answers. And then answers are normally closed, which is either yes or no, true or false. Now, this will rely on a number being, or say a series of numbers being assorted already. Now, you might have a collection of numbers, you might have a collection of prices, for instance, yeah, and you want to find out a certain price within there. Now, what I've done there, I've done a few key symbols, okay? Now, these key symbols look like this. So you've got less than, which is there, okay? Now, less than, so if I say, I've got a number 5 and it lands on number 10, I say, is 5 less than 10? If it's yes, then great, you can eliminate everything that is higher than 10. Or vice versa, if we're looking at say 11, I say, is 11 higher than 10? Is 11 lower than 10? Yes or no? No, so then everything below 10 then will go. Same thing for greater than, so greater than will be there. And also 2 equals. Now, if you notice, there's 2 equal signs there, okay? Now, them 2 equal signs in programming language basically means equals 2, all right? If you just add in 1 equal sign, it won't really work, okay? So you're going to make sure that it's 2 equal signs. Now, an example of binary. So this is how binary searching works. So I've got a target there at the top. If you see there at the top, yeah, I've got a target of 26. Now, if you notice, I've put a little list at the bottom, and I said, okay, make sure the list of numbers are in order. So we've got 19, 26, 39, 50, and 68. Now, obviously, I want to, if I search and say if they're blank, I want to search for the correct answer, which is 26, which is here. Now, the first thing I need to do there is the computer will take the middle number, okay? So the middle number is here, 39, all right? And I'll ask a question of, is 39 lower, you see there, lower than the target, which is 26? If it is yes, then great. So 26 is lower than 39. So what will happen is the computer in binary will just get rid of that one. Oh, it will just get rid of this one here, get rid of that one, and get rid of that one. So now all of a sudden, I'm now left with these two numbers. Now, it will ask exactly the same question, but you ask, how can we get a middle number? Now, the way a computer will work is it will always take the highest number. You see there, it will always take the highest number. So it'll say, okay, 26. Is 26 lower than 26? If it says no, then this then goes, and then it knows that this is the correct answer. So there is a couple of steps in there, okay, to come up with the right answer. Now, I want you to, if you're not understanding me straight away, then go back through it and have a look. But don't forget, the couple of steps are as follows. Target's 26, it will use 39 as the middle number. Is 26 less than 39? Yes. So they will all get binned off. Then we have got here, so we've got two numbers, so we haven't got a middle number. So we just use the highest number, which is there. We'll say, okay, is 26 lower than 26? If it is yes, then it'll drop. But obviously it's no, it's exactly the same, so it can't be lower. So that means 19's gone, and then we leave with 26. Okay, so that's how binary searching works. Now, linear searching. Now, linear searching is slightly different, okay? Linear searching is actually easier for you to understand, but it's a longer way, it's a longer process that it will work. So, if you notice that it's much different because the list of numbers don't need to be in order, so they can be in any order they want. So you don't have to pre-order them beforehand. Now, one of the key symbols is, as again, equals to, which is there, making sure that you've got two equals signs. And yes, that means equals to. If you just put one equals, your program will think you're adding a variable. That's why it adds two equals signs. Now, example. So that target there of 67. So what it will do is it will start from left to right. So it will start here. So it'll go, okay, step number one is this number. Okay, and it'll say, is this number, see, so is this number here equal to the target of 67? If it is yes, then great, the search stops. If it's no, it goes on to the next one. And it'll ask this exactly the same question. Are you number 67? Yes or no? Well, no, I'm not, because I'm 120. We move on. Same again. Are you 67? No. Same again. Are you? No. Are you? Yes. So now we've got our right one, and then we're done. Okay? And that is basically how a linear works. So it's in a straight line. It'll start from the start and it'll plow its way through. Now, obviously, if you think about it that way, your binary searches have got a lot less steps. Say if my 67 was down here at the end, okay, it would have to go through 1, 2, 3, 4. It would have to go through 5 questions before it gets to the answer, whereas the binary search only goes through about 2. So it's a faster process, the binary, and the binary search is a lot common in a lot of programs now. So make sure that that you understand both of them and the differences between them. Okay. Now, task. So this task needs to be done in your books. All right. Now, don't forget what I've done is I've put this PowerPoint on the VLE for you, and it's under key videos. Now, I've also put on there another video that explains this as well, just in case you're not understanding it from me. There's somebody else on there that I found on YouTube that might be useful for you. Now, what I would like you to do is I would like you to explain this step by step in terms of binary. So this line of numbers here with the targets of 72. And I would like you to explain this line in terms of linear search, okay, the target of 21. Now, what you need to do is you need to explain it as a step-by-step, an algorithm, okay? So these are your questions that you will do. Now, I would like your work to be laid out like the following, okay? So at the top, your target. So you might put binary search as a subheading. and then you'll have target equals 72, for instance. And then you'll write down the number line like that. Then underneath, so your first step is to find the middle number, which is 56, which is there, 56. The next step is it will ask a question of, is 56 less than 72? Well, is 56 less than 72? Yes, it is. Good. So then you move down, okay? So then all these will all go, and then all of a sudden then you've left with these, okay? Then you take 94, and you say, is 72 less than 94? Well, yes, it is. So that will take the 2 steps, okay? Now, you need to explain it in little bullet points underneath each one, so you will have this underneath a subheading called binary, and then just this clear steps underneath. Same for linear, with the linear steps underneath as well. Alright, and the steps should be questions, okay, which is there. I should have actually put a bracket on there, that's why I got a bit confused before, okay. Yeah, so is 56 less than 72, okay. So that is what you need to start to think, alright, and you need to start asking them questions and then coming up with the answers in the actual bullet points underneath, and that will get you started off. Now, when you've done that, so you've made your notes in terms of your steps, in terms of your binary and your linear from beforehand. You've done these 2 tasks here, so you've done binary searching there, you've done linear searching for there. You then need to research into the compare and contrast part. So you need to come up with the good things and bad things for each. Now, that can either be done in your booklets or on the computer. I don't really mind. All right, but as I say, you can do that in a table, so you can have binary search, so what's good about it, what's bad about it, and then linear, what's good about it, what's bad about it also, okay? But that's only when you have finished these, okay? So these targets, these binary searches and linear searches, okay? If you need any help, I will be on my emails. I apologise I can't be in today, but I will be on my emails, so I'll be able to help you every step of the way. It's not a problem at all. So you can just sort of ask me any questions you want. That's no problem at all, and I'll be in front of my computer and I'll be able to send you a response back straight away. Okay, guys, cheers.